Right, Lamai. Today we are going to discuss our 16th paper. In this paper, we will discuss questions related to equation of motion, graph, and motion under gravity. Pute, let's see the questions. Right, Pute, let's see the first question. A motor car travels at uniform velocity 30 meters per second. The driver of the car sees another vehicle in front of him at 95 meter, which is traveling at speed of 10 meters per second in the same direction. Right, Pute, this diagram shows the motion of two objects at t equals 0, 95 meters with 95 meter separation, right? Then therefore, the driver of the first car applies brake and decelerate uniformly. What is the minimum deceleration that the car must apply to avoid the two cars colliding? Right, Pute? Let's assume that the displacement between the two cars becomes 0 in time interval t. Here you need to know two important points. During this time interval, these vehicles, this vehicle and this car move forward direction. අපි හිතමු during this time interval t, this is the distance traveled by this vehicle, this S. This displacement you can obtain by applying S equals ut for the motion of this vehicle. Uniform velocity of the vehicle is 10, time interval is t, 10t. And then displacement acquired by the car during the same time interval, simple t. That means displacement acquired by the car during this time interval when they meet is 95 from here to here, 95, and another S displacement, 95 plus S. And this S is equal to 10t. Therefore, the displacement of this car when they meet is equal to 95 plus 10t. Right? This is the first point you need to know. Okay, then the second point. The second point is, it is not necessary for the velocity of this car, for the velocity of this car to be equal 0 when they meet to avoid the collision. To prevent the collision, it is sufficient for the velocity of this car to be equal velocity of this vehicle. Then they can move with same velocity. No? Same velocity happen. Right? It is not necessary for the velocity of this car to be equal 0. It is just enough. It is sufficient for the velocity of this car to be equal velocity of this vehicle. Then they can move together. This one is the main point of this question. To prevent the collision, then front with 10 meters per second, velocity of this car should be reduced up to 10 meters. It is enough to avoid the collision. Right? Then you can apply equation for this car. That means this car take displacement 95 plus 10t, and during this displacement, it reduces its velocity from 30 meters per second to 10 meters per second. Right, Pute? By using this data, you can obtain the time taken. Pute, to find the time taken, you can apply this equation. S equals V plus U over 2 into T. Displacement is 95 for the motion of the car. Displacement is 95 plus 10t. Final velocity 10. Initial velocity 30. Divide by 2 time interval t. Then 95 plus 10t. Then 40 divided by 2. 10 plus 30, 40. 40 divided by 2 kiyada 20t. Then the answer is 95 is equal to 10t, 20t minus 10t, no? That means t is equal to 9.5 seconds. Then you can apply V equals U plus AT to find the acceleration. Final velocity 10, initial velocity 20, 30, plus A time taken 9.5. Okay, then plus 10 minus 30, you can bring this plus 30 from here to here, no? Then minus 30 minus 20, minus 30 plus 10, so the minus 20 is equal to 9.5A. Acceleration is equal to minus 20 divided by 9.5, but here you need to mention the deceleration. When this one is the acceleration. Acceleration is a negative value. Why? The velocity reduces, no? Therefore, the deceleration is 20 over 9.5. Got it? Right. Let's see the next question. Right, Budhe, let's see the answer for the second question. The figure below shows the graph of acceleration versus time of an object started from rest. Which of the following statement about the motion of the object are correct? Budhe, before identifying the answer, let's try to draw the corresponding velocity time curve. Uday, you can identify the variation of velocity by using two ways. Why? By using area under the velocity acceleration time curve. Do you remember? Area under the acceleration time curve gives the velocity change, or you can apply here, you can observe that these two accelerations are uniform accelerations. Therefore, you can apply equation of motion to identify separately to identify the velocities, right? Let's try to draw the corresponding velocity time curve. From object is started from rest. Therefore, due to this acceleration during the first phase from t equals 0 to t equal t, this object increases its velocity. You need to identify this final velocity. You can obtain this final velocity by applying V equals U plus AT. Initial velocity is 0, acceleration A, time interval T. And this change is equal to area under the curve. Therefore, the velocity of the object at T equal T is AT. Right. Then you can observe that object decelerate. It is a constant deceleration. Due to this deceleration, object first decreases its velocity. Right. And now now the velocity is 80, no? Then you need to identify velocity at t equal 3 seconds. Again, you can apply v equals u plus at. Now you know initial velocity of the object is at. Velocity increases from 0 to 80, no? Then again, acceleration is minus a, time interval t to 3t, 2t. at minus 280, that means final velocity is minus 80. Velocity first decreases up to 0, then negatively increases. Negatively increase means object turns back and move to the opposite direction. Right? Right. Final velocity is minus 80. Got it? During the first phase, object accelerate. Due to this acceleration, object increases velocity from 0 to 80, then decelerate. For the second motion from t equal t to t equal 3t, you can apply v equals u plus at, then you can observe that velocity, final velocity is minus 80. Okay, then you can find the answer. What is the first statement? At time t equals 3t, the velocity of the object is negative. Yeah, it is negative. Object turns to the opposite direction and moves to the negative direction. Right? Capital A is a correct statement. B, during this motion, object must comes to instantaneously rest at an instant. At this instant, object velocity becomes 0 and turns to opposite direction. Velocity එක 0 කරගෙන opposite direction එකට move වෙලා තියෙනවා. At this point, object is at instantaneously rest. Therefore, second statement is a correct statement. Read the third one. At the time, at time t equals 3t, displacement of the object is negative. It is wrong. You can observe that this one is the displacement acquired by the object due to the positive velocities. And this is the displacement acquired by the object due to the negative velocity. Here you can observe that this positive area is greater than the negative area. Therefore, the final displacement should be a positive value. Third statement is a wrong one, right? Therefore, A and B are correct. Third one is the answer. Right, Pute, let's try to find the answer for the third question. First, read the question. The velocity time graph shown in the figure below shows the motion of a car and a bus. The bus travels with a uniform velocity u on a straight road. As the bus passes a car at rest, the car begins to move and accelerate at a uniform acceleration, simple A, continuously. Right. And the car passes the bus during t naught time interval, t naught, right? Then, which of the following statement or statements about the motion of the car and the bus are correct? Okay. Before identifying the answer, you need to identify the motion of the two objects. Here you can observe that at t equals 0, velocity of the car is 0 and velocity of the bus is u. That means at the starting point, bus passes the car. Why? Velocity of bus is greater than velocity of car, no? Today, here you can observe that up to this time interval, t equals t dash, velocity of bus is greater than velocity of car. That means when you consider a particular time interval, displacement acquired by the bus is greater than displacement acquired by the car. Got it? Therefore, up to this point, gap between the two objects increases. Got it? Then, from this point, you can observe that velocity of car is greater than velocity of bus. That means, when you consider a particular time interval from this point, you can observe that velocity of car is greater than velocity of bus. Therefore, when you consider a particular time interval, displacement acquired by the car is greater than displacement acquired by the bus. Therefore, gap between two objects decreases. ඒ කියන්නේ පුතේ මේ point එකට එනකන් gap between the two objects increases even if the velocity of the car increases. But from this point, gap between the two objects decreases. Why? What is the reason? From this point, velocity of the car is greater than velocity of the bus. Got my point? Therefore, you can say මෙන්න මෙතනදි තමයි ළමයි මේ ඔබ්ජෙක්ට් දෙක කා එකයි බස් එකයි අතර maximum gap එකක් තියෙන්නේ. Right? The maximum gap between the two objects exists possess at this point. Got it? Up to this point, gap increases. From this point, gap decreases. Got it? First, you need to identify the correctness of the B statement. To identify the correctness of the B statement, you can assume that velocity of the car when it passed the bus is v, then you can derive an expression for the velocity v. Okay, here you need to know two important points. The first point is by the time when the car passes the bus, the displacement acquired by the car should be equal to the displacement of the bus. The second point is velocity of the car should be greater than the velocity of the bus. Got it? Then you can obtain this velocity by equating two displacement. This is the displacement acquired by the car, half into base t naught, altitude v. It should be equal to the displacement of the bus, u into t, area of this rectangle, u into t naught. Then t naught to t naught cancel out, v is equal to 2u. Putala, did you see when you find this answer, you didn't use the acceleration of the car. That means acceleration of the car doesn't depend on this velocity, right? Therefore, B statement is a correct statement. Right, Pute? Let's try to find the correctness of the third C statement. Then to find the correctness of the C statement, you can consider the gradient of the velocity time curve of the car. Okay, gradient of velocity time curve tan alpha gives the acceleration. Then you can write here tan alpha as 2u. Now v is equal to 2u, no? 2u over t naught. 2u over t naught a. When you find this time interval, you need to use this acceleration. That means this time interval depends on the acceleration. That means C is an incorrect state. Got it? Today, then you can identify the correctness of the simple A statement. Today, before finding the correctness of the simple A statement, you need to find this time interval. To find this time interval, you can use the gradient of this velocity time curve of the car. මේ ළමයි එයාගේ gradient එක බලන්න m equals tan alpha gives acceleration. Today you can write this tan alpha as 2u over t naught or u over t dash. This one is u, this one is t dash. It is equal to simple A. Then you can identify u to u cancel out. You can subject t dash. T dash is equal to t naught over 2. Right, put it. T is equal to t naught over 2. Now you know when the velocity of the two objects equal, time taken is t naught over 2. Right? Put it. Then you can identify displacement of the two objects. Put it. Let me explain. This one is the velocity time graph of the car when their velocities are equal. This one is the velocity time curve of the bus, right? Then you can identify, now the time is t naught over 2. Velocity is u. So you can identify displacement acquired by the bus when the two velocities are equal. It is equal to this area, u into t naught over 2. And also you can find the displacement acquired by the car when the two velocities are equal. It is equal to half into base t naught over 2 altitude u. It is equal to t naught u over 4. Then you can identify the maximum gap between the two objects. It is the difference between the two displacements. It is equal to ut naught over 2 minus ut naught over 4. It is equal to ut naught over 4. This one is the maximum gap when the maker between the two objects. Therefore, simple A statement is a correct statement. Right, Pute? Simple A, Hari. Right? Therefore, both A and B statements are correct. Right, Pute? Let's try to find the answer for the fourth question. A ball dropped from a top of a tower fall 25 meter in the last seconds. Pute. Yeah, වැටුණා කියලා කියන්නේ initial velocity is equal to 0. Then the gravitational acceleration is 10 meters per squared second towards the downward direction. And it moved 25 meters during the last seconds. Today, you need to assume that it takes simple t time interval to move from here to here, from the initial point to a point located 25 meters above from the ground. අපි හිතමු මේ time interval එක t කියලා, right? Then displacement acquired by the particle during this time interval is s. Right. Now you can find the height. Height is equal to s plus 25, no? Right. You can write an expression by considering motion of the object from t equals 0 to t equal t. You can apply s equals ut plus half at square. From here to here, displacement is s, initial velocity 0, half into gravitational acceleration 10 t square. then S is equal to 5t squared, right? This one is the first expression. Today, you can derive another expression by considering the motion of the ball by considering the entire motion. Now, you know, from here to here, time taken is t. During the last second, it moves 25 meter. No? Therefore, total time interval is t plus 1. I put a method in the 1 seconds. Got it? Then you can write an expression by considering the motion between time interval t equals 0 to t equals t plus 1. Right. S equals ut plus half at squared towards the downward direction. You need to mention the direction. Total displacement is s plus 25 from here to here s. Then another 25 meter. Initial velocity 0. Half into acceleration 10. Time interval t plus 1. Here you have applied the equation for the entire motion. No? From here to here t and another 1 second t plus 1. Total time interval is t plus 1 squared, right? Then s plus 25 is equal to 5 times t squared, square of the first term into second term into 2 and square of the last term. Then s plus 25 is equal to 5t squared plus 10t plus 5. Today, you have obtained an expression for the 5t squared. 5t squared is equal to s. Ne? Instead of this 5t squared, you can substitute s. I mean, 5t squared is equal to where is equal, all right? Then s plus 25 is equal, you can substitute s for 5t squared and 10t plus 5, right? Then s to s cancel out. You can bring this term from here to here, then 20 is equal to 10t, t is equal to 2 seconds. Therefore, total time interval is equal to 3 seconds, right? But you can find that you need to find height of the object. This height from here to here, s equals 5t squared, t is equal to 2, no? 2 squared, then 5 into 4, 20 meters. And total height is s plus 25, 20 plus 25, answer is 45 meters. Right, second one is the answer. Right, Bhude, let's try to find the answer for the fifth question. A ball is projected freely to a floor a height of 1 meter. Height is given as 1 meter, right? If its speed is reduced by 25% at each bounce. Bhude, එයාගේ ස්පීඩ් එක 25% 1/4 වලින් reduce වෙනවා කියන්නේ ළමයි 4න් එකක් අඩු වෙනවා කියන්නේ 4න් 3ක් ඉතුරු වෙනවනේ. Right. Therefore, first of all, you need to find the velocity of the ball just before the collision. To find the velocity of the ball just before collision, you can apply v squared equal u squared plus 2a. This equation towards the downward direction. V squared initial velocity 0, 2 into gravitational acceleration 10, height 1. Then square root 20 is equal to the velocity of the ball just before collision. This velocity is equal to square root 20 meters per second. Then, according to the question, if its speed is reduced by 25% at each bounce, then you can obtain velocity just after to the collision. පුතා 4න් එකක් 25% mean 1/4 no. 4න් එකක් අඩු වෙනවා කියන්නේ බං 4න් 3ක් ඉතුරු වෙනවා කියන එක. Right, 3/4 remain. Therefore, velocity acquired by the ball just after to the collision is u2 කියලා ගමු. u2 is equal to මෙයාගෙන් 4න් 3ක් 3/4. This one is the initial velocity of the ball just after to the first collision. Then it reached to maximum height due to gravitational deceleration. Velocity decreases, then again falls down to the earth. Today, when this particle returns to its initial position when the vertical displacement is equal to 0, speed are same. මෙයාගේ upward speed එකමයි මෙතෙන්දි මෙයාගේ downward speed එක. It is equal to root 20 into 3/4. මතකයිනේ? Then you can obtain velocity acquired by the particle just after to the second collision. Just before it is equal to root 20 into 3/4. Made velocities the k magnitude equal. Then you can obtain u3. First collision, second collision. u3 is equal to root 3 may velocity again ආපහු 3/4 නේද පුතේ? That means root 20 times 3/4 squared. Right. මේක තමයි just before the collision, just after velocity of the particle just after to the collision කියන්නේ එකෙන් ආපහු අතරින් තුනක්. ඒ කියන්නේ මේකේ squared එක වෙන්නේ. Then it again reached the maximum height and falls down. Then you can obtain velocity of the particle just after to the third collision. First collision, second collision, third collision. u4. It is equal to root 20. පුතේ මේ ස්පීඩ් එකෙන් මුඩට ගියා ආපහු ඒකෙන්ම පොළවේ වදිනවා. ඒකෙන් ආපහු අතරින් තුනක්. 3/4 squared වලින් ආපහු අතරින් තුනක්. Then the answer is root 20 3/4 to the power 3. Right. This one is the velocity of the particle just after to the third collision. Then you can obtain maximum height. To obtain maximum height, you can apply v squared equal u squared plus 2a at the maximum height. Velocity is 0. Now we know the initial velocity. It is equal to root 20 3/4 to the power 3 squared plus 2 into minus 10 into s. Right, Pute? Then you can bring this term from here to here. 20s is equal to 20 into 3/4 to the power 3 into 2, 6. Then the answer is s is equal to 3/4 to the power 6. Fourth one is the answer. Right, Budhe, let's see the answer for the question number 6. A person simultaneously drops an object and throws another object vertically downwards from a certain height, capital H. Which of the following graph best represent the velocity time curves for the two objects? Curve A represent the dropped object and curve B represent the thrown object. Right, Budhe. First object, capital A, released from initial velocity 0. Second object throws with initial velocity u. Puthe, you can to identify the variation of velocity with time, you can derive an expression for the two motions. Puthe, when you consider the motion of capital A, you can apply v equals u plus at towards the downward direction. Initial velocity is 0, no? That means v is equal to 0 plus g acceleration, gravitational acceleration g into t. V equals gt. That means the shape of this variation is y equals mx. Then you can derive another expression for the motion of capital B. V equals u plus at, you can apply towards the downward direction. Then v is equal to initial velocity u, acceleration g into t. Then v equals gt plus u. Okay, this one, what is the general equation? Y equals mx plus c. Okay, for these two variation, you can observe that the gradient are same. Here the gradient is g, same gradient. Then you can draw the shape of the two curves. Variation of velocity of A with time is y equals mx type curve. No? Variation. Then when you consider the variation of velocity of v with time, එයාට intercept එකක් තියෙනවා. Intercept is c. Then it has same gradient. Same gradient mean two curves will make same angle with the positive direction of the x-axis. අයි බං gradient එක කියන්නේ මේ tan alpha නේ. Gradient same කියන්නේ these acute angles are same. Therefore, the two curves should be parallel. Answer එක වෙන්නේ පුතේ එතකොට first එක. Right? First, you need to identify the variation. To identify the variation, you can apply this equation for the both object. Then you can identify the general equation. This one is y equals mx type curve. This one is y equal mx plus c type curve. And then you can observe that gradient of both curve are equal. That means they are parallel curves. Got it? Right, Pute. Let's see the next question. Right, Pute, let's see the answer for the question number 7. A ball is thrown vertically upwards from the ground. Initial velocity of u කියලා ගමු. Reach to maximum height, then falls down due to gravitational pull. The time duration between the two instances that the ball passed the point at a height of 25 meters. This height is given as 25 meters. On its path from ground is 4 seconds. This time interval is given as 4 seconds. Okay, do you remember? Except this maximum height. මේ maximum height එක ඇරුණම අනිත් හැම displacement එකක්ම ලැබෙන මෙයාගේ motion එකේ there are two instances. When the object move upwards, when the object move downwards. එතකොට පුතේ තව important point එකක් තියෙනවා you should remember. This motion from this displacement to maximum height and maximum height to same displacement. These two motions are symmetrical motion. That means magnitude of these two velocities are equal. Time taken by the particle from this displacement to maximum height and maximum height to given displacement. These two time intervals are same. That means if the total time is t, from here to here t, 4 seconds, this one should be 2 seconds. Time taken by the particle to move from this given displacement to maximum height should be 2 seconds. Then you can identify the motion of the object from this displacement from 25 meter to initial velocity u, අපි මෙතන velocity එක u dash at the maximum velocity v0, initial velocity equals 0 at 25 meter height. Time interval, initial time interval is 0 at 25 meter height. Time interval is t. Then it reach up to maximum height during another 2 seconds. Then the time interval is t plus 2 seconds. Got it? t plus 2 කියලා ලියාගමු. ඇහිලමයි එහෙම ගත්තේ. මෙයා මෙතන ඉඳලා මෙතෙන්ට 4 seconds නම් මෙතන ඉඳලා maximum height එකට 2 seconds. Got it? Then you can identify this velocity by considering the motion from this height to maximum height. You can apply equation from t equals t plus 2 seconds. You know the gravitational acceleration. You can apply v equals u plus at towards the vertically upward direction. At the maximum height, velocity is 0. Initial velocity u dash. Gravitational acceleration minus 10. Time interval from here to here 2 seconds. Object obtain maximum height during 2 seconds. That means velocity at the height 25 meters is 20 meters per second. Okay, then you can obtain, now you know the velocity of the object at the maximum at the 25 meter displacement. Okay, then you can apply equation v squared equal u squared plus 2as to identify the initial velocity at t equals 0. You can apply equation from t equals 0 to t equal t. During this time interval, u dash is the final velocity. It is equal to 20, no? 20 squared initial velocity you need to find. 2 into acceleration. Here you have apply equation towards the upward direction. Therefore, this one should be minus 10. Displacement from here to here 25. Then 400 u squared minus 500. You can bring the term from here to here. Then 900 is equal to u squared. U is equal to 30 meters per second. That means initial velocity is 30 meters per second. Right, Pude? Which one is the answer? Third one is the answer. Right. Right, Baran Lamai? Consider the motion of an object released from rest from a height capital H. Which graph best represents the variation of height simple h of the object above the ground level with the time? You need to identify variation of height with time. Uday, let me explain. First, you need to draw a diagram to identify the motion. T equals 0 object. Consider the motion of the object released from rest. That means initial velocity is 0. Initial height capital H. During simple t time interval, displacement, if the displacement acquired by the object is s and height h, height is measured from the ground, no? Which graph best represent? You need to obtain variation between h and t. Simple h and t. To identify the velocity v dash kilo. Acceleration, gravitational acceleration g. Uday, you can apply this equation. First, you need to identify the general relation here. It is to identify this relation, you can apply equation s equals ut plus half a t squared towards the downward direction. Uday, you can mention this displacement. Uday, simple h plus s is equal to capital H. No? Therefore, this displacement is equal to capital H minus simple h. You can substitute capital H minus simple h instead of displacement. Initial velocity 0. Gravitational acceleration g, time in squared, e squared. Then you can subject simple h. Easy name. Melamai. Capital H minus simple h is equal to g t squared over 2. Then you can subject h. Capital H minus gt squared over 2, h minus g over 2 into t squared. H, Pude, do you see the relation? What is the general relation? Y equals minus mx or x squared. Here you need to draw the relationship between t and h, not t squared h. T and h, then x squared plus h. Got it? Right. Therefore, the shape is y equals minus mx squared plus h, intercept is equal to capital H. Right, Pude. And here you need to identify this time interval. Not only the shape of the curve, but also you need to identify the time interval. shape class to identify the time interval, you can apply this equation. V squared d, s equals ut plus half a t squared. When it hits the ground, displacement is equal to capital H, no? Initial velocity 0, half into gt squared. 2h over g square root is equal to t. This time interval is equal to 2h over g square root. What should be the answer? Second one. Got it?